Temperature controls almost everything around us. The weather outside your window, the food in your fridge, even the stars burning in distant galaxies. But the temperatures we experience every day are only a tiny slice of what actually exists in the universe. On one end of the scale, there are places so cold that atoms nearly stop moving. On the other end, there are temperatures so hot that matter itself begins to fall apart. From comfortable room temperature, to deserts hot enough to melt roads, to the unimaginable heat of exploding stars. Today, we're climbing the entire temperature ladder, level by level, to see just how extreme the universe can get. Level 0, the human comfort zone, 0 degrees Celsius to 30 degrees Celsius. Most human life exists within a surprisingly small temperature window, roughly 0 to 30 degrees Celsius. Inside this range, the world feels normal. Plants grow, animals thrive, and humans can go outside without specialized gear. Room temperature, usually around 20 to 25 degrees Celsius, is where our bodies perform best. Your internal temperature stays stable. Sweat isn't needed. Shivering doesn't start. It's the sweet spot where life functions smoothly. But the reason this zone feels so ordinary is because our bodies evolved specifically for it. Move too far outside this range, and the balance quickly breaks. Which brings us to the first step into the extremes. Level 1. Mild extremes. Minus 10 degrees Celsius to 40 degrees Celsius. Just outside the comfort zone lies what we might call mild extremes. These are temperatures most people have experienced at least once. On the cold side, minus 10 degrees Celsius is common during winter in places like Canada, Northern Europe, and parts of Russia. Your breath turns into fog. Car engines struggle to start, and exposed skin begins to sting from the cold. It's uncomfortable, but with warm clothing, humans adapt easily. On the hot side, 40 degrees Celsius is a different story. Cities like Phoenix, Dubai, or Delhi regularly reach these temperatures in summer. At this level, the body works overtime to cool itself. Sweating increases, dehydration becomes a risk. Shade suddenly becomes valuable real estate. Still, life continues normally. People go to work. Cities function. But push the temperature just a little further, and the environment becomes genuinely dangerous. Level 2. Dangerous heat, 50 degrees Celsius range. At around 50 degrees Celsius, heat stops being uncomfortable and starts becoming life-threatening. Some of the hottest inhabited places on Earth reach these temperatures during severe heat waves. In Death Valley, California, the highest reliable air temperature ever recorded reached 56.7 degrees Celsius in 1913. Step outside in that kind of heat, and the air feels like it's coming from an oven. Your body relies on sweat to cool itself. But when temperatures climb this high, sweat evaporates too slowly to keep up. Your internal temperature begins to rise. This can lead to heat exhaustion and eventually heat stroke, a medical emergency where the body can no longer regulate its temperature. Infrastructure struggles too. Road surfaces soften, vehicles overheat, power grids strain as millions turn on air conditioners. Extreme heat waves are now considered one of the deadliest natural hazards on Earth. But while heat pushes the body to its limits, cold can shut it down even faster. Level 3. Extreme cold, around minus 50 degrees Celsius. At roughly minus 50 degrees Celsius, survival without protection becomes extremely difficult. This level of cold is common in parts of Siberia and northern Canada during winter. The Russian town of Oymyakon is famous for being one of the coldest inhabited places on Earth. Here, temperatures regularly drop below minus 50 degrees Celsius. At this level, even everyday tasks become complicated. Cars must stay running continuously because turning the engine off can cause fuel and oil to freeze. Breathing the air feels sharp and painful, and exposed skin can develop frostbite in just a few minutes. Frostbite occurs when body tissues freeze, damaging skin and nerves. If exposure continues, the body's core temperature begins to drop. This leads to hypothermia, a condition that slows the heart, brain, and muscles. Without immediate shelter, survival time can shrink rapidly. But Earth still holds even more extreme environments. Level 4. Earth's absolute extremes. Beyond normal climates lie the true frontiers of our planet. The coldest air temperature ever measured on Earth occurred at Vostok Station in Antarctica, where scientists recorded minus 89.2 degrees Celsius in 1983. At this temperature, even breathing unprotected air can damage lung tissue, metal becomes brittle, Fuel thickens like syrup. The environment feels more like another planet than Earth. On the opposite side of the scale, the Lut Desert in Iran holds the record for the hottest ground temperatures ever measured. Satellite data has detected surface temperatures above 70 degrees Celsius. That's hot enough to cause severe burns within minutes. But Earth also hides one of its most surprising extremes deep under the ocean. At hydrothermal vents on the ocean floor, superheated water can erupt at over 400 degrees Celsius. Under the crushing pressure of the deep sea, water doesn't immediately boil. And astonishingly, certain microorganisms thrive there. Life that survives in temperatures once thought impossible. Level 5. Beyond human survival. Now we leave normal environments behind and enter conditions that humans simply cannot survive. One example is liquid nitrogen, widely used in laboratories and medicine. Its temperature sits at -196 degrees Celsius. At this level, objects freeze instantly. A flower dipped into liquid nitrogen becomes so brittle it can shatter like glass. Human tissue exposed to this temperature freezes almost immediately. On the hot side, some microorganisms known as hyperthermophiles can survive in environments above 100 degrees Celsius. Certain species thrive at 121 degrees Celsius, temperatures that would instantly kill almost all known life. These organisms live near deep-sea vents where heat and pressure create one of the harshest ecosystems on Earth. But Earth is still relatively moderate compared to the rest of the solar system. Level 6. Solar System Extremes. Outside our planet, temperatures become far more dramatic. Take Venus, often called Earth's evil twin. Its thick carbon dioxide atmosphere traps heat through a runaway greenhouse effect. Surface temperatures reach around 460 degrees Celsius, hot enough to melt lead. Space probes sent there by the Soviet Union survived only a short time before being destroyed by the intense heat and pressure. Meanwhile, some permanently shadowed craters near the Moon's south pole reach temperatures near -250 degrees Celsius. These regions are colder than Pluto. At temperatures like this, gases can freeze solid. Even spacecraft electronics must be carefully insulated to avoid freezing. Across the solar system, planets and moons display extremes far beyond anything humans naturally experience. But the universe itself goes even further. Level 7. Human-made extremes. Interestingly, humans have created temperatures even more extreme than many natural environments. In steel furnaces, temperatures reach around 1,500 degrees Celsius, hot enough to melt rock and metal. But modern science has pushed far beyond that. Experimental fusion reactors designed to replicate the power of the sun heat plasma to over 100 million degrees Celsius. That's hotter than the center of the sun itself. Magnetic fields are required just to keep the plasma from destroying the reactor walls. Meanwhile, laboratories have also created the coldest temperatures in the known universe. Using advanced cooling techniques, scientists have chilled atoms to billionths of a degree above absolute zero. At these temperatures, matter begins behaving according to strange quantum rules. Atoms move together as if they were one giant particle, a state known as a Bose-Einstein condensate. But even this is still not the ultimate limit of temperature. From comfortable room temperatures to scorching deserts, to the unimaginable heat of exploding stars, temperature defines the boundaries of life, physics, and the universe itself. And the incredible part is that humans have explored nearly every level of this scale, from the coldest atoms ever created in laboratories to machines trying to recreate the power of the sun. Which makes you realize something strange. The temperature outside your window right now is sitting quietly inside the most fragile zone of all, the one that makes life possible. And compared to the rest of the universe, it's almost unbelievably perfect.